our companies, our main business is the manufacturing of components for the internal combustion engine, mainly gaskets, but also some other components. But in 2002, the president of the company wanted to diversify the business, and we thought that the hydrogen technologies was a good opportunity. So we are working more than 20 years with hydrogen technology, mainly focused in the developing of the fuel cell stack, which is a component that generate electricity, as you know. So the presentation is in Spanish, but last night I could get some of the slides also in English, so I will change the presentation from one slide to another. And if I have some problems with the English, my friend Juanjo will help me to translate some technical words maybe, or some expressions. Okay, the first is our business in fuel cells. The company started in 2003 to develop stacks. In the first years, we developed some small demonstration projects focused in the automotive, scooter, and you know, in 2003 you could see a small car. And from 2015 and to 2020, we developed also some stationary applications with fuel cells, like a micro-combined heat and power system, and also a backup system. But in 2020, more or less, we changed again the development to the automotive industry, to the transport applications. And we have developed since then several stacks with higher power and some demonstration projects that we will see later around the application of fuel cell systems in heavy-duty transport. Because really at the end, in automotive industry and small cars and so on, most of the electrification will be done with batteries, as you know. And the only business that could be for the fuel cells and the hydrogen will be the heavy-duty transport. Okay. This is the presentation of what is a fuel cell system, but it's in Spanish, and this one is in English. Maybe if you have seen, or if you have already have some explanation of fuel cells, you know some of these components. A fuel cell basic system has a stack is in the center, which is the electrochemical reactor that transforms the hydrogen and oxygen energy to electric power, and has different circuits. The blue one is the circuit of the air. The red one is the circuit of the hydrogen. Okay, I'm not sure which is this color. Turquoise. Is the cooling circuit. The black line is the fuel cell control system, the unit control system, and the orange one is the power, the exit power to the electrical engine. And each one of these circuits has many components. Fuel cell system is a complicated system. It's not only the stack, there are many other components. So the fuel cell vehicles are more complicated than a battery vehicle. Not as complicated as internal combustion engine, which has hundreds of parts, but it's something in the middle between a pure electric battery car and an engine, an internal combustion engine car. For example, we can start with the air circuit. We start with I think that it is not shown, but it's a filter, special filter with carbon, because it is necessary to supply the air to the stack very, very clean, without any contaminants. So it's a special air filter in all the fuel cell systems. After that, we have a mass flow meter to control the stoichiometry of the reaction. Must be very well controlled. The amount, the mass of hydrogen and the mass of air to be supplied to the stack must be very, very fine control. So we have here a mass flow meter. After that, we have a compressor, air compressor. That is an electrical compressor to compress the air, like in the turbos in the internal combustion engines. And after that, an intercooler, very similar to some applications also in the traditional engines, because the air at the outlet of the compressor is between 120 and 150 degrees, but the fuel cells normally works at a lower temperature, normally between 70 and 80 degrees. So it is necessary the air to cool down, and that's why it is necessary an intercooler. ¿El láser? ¿Cómo funciona el láser? Yes. The laser works. This is the intercooler. Much better, thank you. If you have any question, you can stop me and ask everything. Continuing with the air circuit, this component is also very important. It's a humidifier, because it is necessary to maintain the humidity of the fuel cell very high, and the air is supplied in the compressor very, very dry. So these components, what the function of this component is to translate the humidity of the outlet air to the inlet air, because as you know, the fuel cells produce electricity but also produce water. So the water in the outlet of the air with this component is a humidifier. Some of the water is translated to the inlet air to humidify the air, and then the stacks works better, has better electric efficiency. And but sometimes we have too much water. The fuel cell stack is a component that the quantity of water must be carefully controlled, because if you have very dry air, the fuel cell stack efficiency is very low. But if you supply a lot of water, you may have flooding in the stack, and then the electric efficiency again is down. So in these circuits, sometimes we bypass the humidifier and supply dry air directly when the conditions of the stack is flooding, is a lot of water, so we bypass the humidifier. And this control is made with these electric valves that control the pass of the air in bypass, or directly to the outlet, or directly to the stack. Depends of the point of the function point of the stack. And this is mainly the components of the circuit. Some question? No? Did you know these components? No. No? It's the first time? But you have studied before fuel cells? Some things, but not deeply. Okay. Okay. We will see now the air circuit is the most complex circuit. The other circuits are less complicated. The hydrogen circuit start with the hydrogen that in the transport application normally is stored in compressed tanks at 350 bars for some applications and 700 bars for other applications. The more pressure you have in the tank, the most mass of hydrogen you can store, and then you have more range in the vehicle. So the range in the fuel cell system depends of the mass that you can store here. So in some application, for example, the Daimler group, Mercedes. Oh, something is going wrong. Oh, okay. 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 Daimler Group, Mercedes, is developing a electric truck, heavy truck with fuel cell systems, and for having a long range autonomy, they are developing a tank of liquid hydrogen. The hydrogen is stored at minus 254 degrees, and in this case you can store a lot of mass of hydrogen. But normally it's in gaseous phase. And after the tank of hydrogen, we have this component, which is the injector of hydrogen, which function is mainly regulate the pressure at which the hydrogen is supplied to the stack. Normally, both the hydrogen and the air must be at the same pressure, because internally in the stack, we will see later, there is a membrane which is very, very thin, and the pressure in both sides must be more or less the same, because if not, the membrane could break. So the compressed air normally is supplied at 2 bars of pressure, more or less. And